Alright, good day. Monitoring temperature now. Just going over the code, not really showing how it's simulated in the Cayenne dashboard. But it's good to get a good interview into this so that you can kind of understand it yourself. As always, debug times helps you understand what the current time is at when it's entered into this function. It's pretty useful. Okay, so the first thing is we see whether the temperature is within the desired set point. So, okay, room temp. Keep this in mind. Room temp is the temperature we want it to be next to. So in our Cayenne function for room temp, we are constantly updating this variable, and it's a global variable. So that is this value here, 74. And if I increase this, $75. So 75 is now this value. Okay, cool. So BME temp obviously goes with the BME 280 temperature data. And if you wanted to see that real quick, that is here, BME temperature. We get this full packet for temperature. We get it here. Here is simply, it's in Celsius, so we do the simple math function to get it into Fahrenheit, and then we add it here. We add it here to the data that's sent later in Cayenne. So now room temp plus 2, that is, since now 75, 76, 77. So right now this value is 77. BME temp is this value, 76. So is 77 greater than 76? Yes. And so another condition that must be met is BME temp greater than room temp minus 2? So right now it's 76, and room temp is 75, so 73. Is 76 greater than 73? Yes. Cool. So we know that this if statement is definitely gonna be called. Let's actually be careful with this. So okay, hopefully we didn't mess anything up there, but it should be fine. Let's just put our cursor here. So now it's gone to this last parenthesis, so we know which one it belongs to, which is perfect. And just the neat thing, if we go to this one, it belongs to that one, and this one should belong to this one. Cool. So then that means that we are constantly entering into this function, which is updating hot and cold to be 0. Okay, so since these two are zeros, what do we expect on the dashboard? Well, as we see, we expect these two to be off, and that's why it is off currently, because we're within 2 degrees of the set point. Okay, so now let's increase this value until we get a difference of 2 degrees. So 78. Let's go one more. Okay, so 79. So now we're 79 degrees is our desired temperature. As we see, the cold indicator has turned on and our air vent has turned off. So why is this? So let's go to that specific one where it is too cold. So we're below set point temperature, meaning the room inside. So room inside is below set point temperature. It's below 2 degrees from set point temperature. Means it's cold in here. Okay, so BME temperature, which right now is reading 76. So this value is 76. And room temp minus 2, well, right now it's 79. So 79 minus 2 is 77. And 77 is in fact less than or equal to 76 is less than or equal to 77. So that's why this statement is following into this if statement. Okay, so what happens is we, in the same way as we are doing like the motion and the moisture, air vent state is kind of similar. So is it open? Meaning, so if we go here, air vent is air vent. So what we're asking is the air vent open? Is air vent or is status equal to 1? That's what we're asking. So here, is this equal to 1? Is state equal to 1? Okay, well, right now, let's assume that it is, right? Because it did enter into this function. So, or is the air vent in state 2? Meaning it's idle. So is this 2? Is it idle? Well, apparently it could have been either one of these two cases. But for now, let's just assume that it was in fact on. And if you remember, it was on because it was too hot. So the air vent was open. So if the air vent was open, now what we want to do is we want to close the vent. And here we set it to servo max. But since it is flipped inside the home, we have PWM servo max means that we are closing the vent. Here we have a little delay to allow for the PWM to config. Now we set state equal to 0 and we update the channel for the air vent state, updating struct data for the this should be air vent indicator. So if this state is 0, then oops, oh no, excuse me for that. Alright, if that was 0, then this is 0, and that's what we get, and that's what we see here. So also, if the temperature character array was hot, meaning if this was hot and we're in this situation, we want to turn the hot off. So we want to turn the hot indicator off, and we update that as well so that this actually turns it off. So updating the struct data for the hot indicator so that this actually does turn off whenever we get to this case, because if we suddenly jump to this situation, we wouldn't have this turn off. We need to actively write that it will turn off and that this one will turn on. So now we set cold equal to 1, which means data published 23, channel 23, we make it 1. So here F is now 0, which means that, guess what, this is not hot anymore. If this is 0, right, we're not going to enter it back into this statement because it has already been said that F is 0, which means it is actually satisfies this if statement. But that is if it becomes now too hot. So we'll go ahead and see that in a bit. So let's actually recap. So this one was pretty straightforward. This one a little bit more complex, but if the air vent was open, meaning that this was set to on, oh look, so now it's increased the temperature to 77, which means that this indicator turned off, and that means that this now is satisfied. So hot and cold should be 0, and that's how it updates channel 22 and channel 23. So channel 22 and channel 23. Okay, but now let's decrease this. Let's continue to decrease that. Some motion happening inside. Motion was from the air vent. So we went 2 degrees below 77. So now we see that this needed to turn off, and this needed to turn on, and this needed to turn on. And so since the air vent moved, we saw some motion. So that's kind of neat. So let's look at the situation where it is above set point temperature. It's too hot in here. So right now BME temperature is 77. let's actually use these for my sake to help me there. And then what's going to be the value of room temp? So right now it's room temp 75. So room temp plus 2 is now 77. So we see that this is in fact the situation where 77 is equal to this 77. So we see that we are entered into this state. So air vent, was it closed? Well, from this situation, we made the air vent state closed. So yes, this was in fact 0. State was equal to 0 earlier. Or is it idle? So we know that it for sure was closed because we had it too cold at one point. So then we open the servos. We open the servo, which means we open the air vent. We set the state equal to 1, which means instead of it being closed, air vent is now open. So state is now equal to 1. So now when we get in here, we're not going to continuously be opening the vent. We only want to open the vent just once. And we update channel 24, which is our air vent, and that means this indicator turns on. Cool. So now we need to turn the cold indicator off. And so the way we do that is we set the temperature F. Is it cold? Well, originally it was on, right? Because it was cold. But now we don't want it to be on. So what we do is we set it to 0. And channel 23, as we saw above, channel 23 is the cold indicator. So now it's turned off. Finally, our hot needs to turn on, channel 22. And just to see that's that hot channel there. And now F is equal to 1, which means that every time we enter into this statement, we won't continuously go into this if statement either. We won't say, oh, it's on, or it's off, it's off, it's off. We'll just say it once, and that'll be enough. And so these character arrays help us do that one-time limit. It's good to kind of dive a little bit more deeper into that, but that is its purpose, is to allow us only to go into this if statement once when it is satisfied. Great, thank you.